In today's video, we'll go over several sample problems about who is a stronger nucleophile. First problem, who is the weakest nucleophile in a polar aprotic solvent? The trick here is to memorize polar aprotic strong nucleophiles point upwards, and so the strongest one is going to be fluorine for polar aprotic, so the weakest one must be iodide. As for polar protic, we memorize the strength of nucleophiles for this solvent is going to point down, so iodine is going to be the strongest polar protic nucleophile, and it is going to be fluoride that's going to be the weakest nucleophile in a polar protic. However, I want to note that the identity of the nucleophile doesn't really matter in an SN1 reaction, okay? SN1 reaction, which sometimes is polar protic solvent. The only thing that matters in SN1 reaction is the concentration of the nucleophile, not the identity, okay? So other thing I want to note here is aqueous. It's another way of saying protic solvent. A protic solvent is something that can hydrogen bond, such as a solvent with H bonded to an N or an O. Alright. In a protic solvent, who is more nucleophilic out of these three? So protic, we memorize that this is a direction for a protic nucleophilic strength. It's down, so S is lower than O. It's going to be this. But the problem is, in an aprotic solvent, who reacts faster, which is just another way of saying who is a better nucleophile. This is a trick question, okay? So we remembered that nucleophilic strength increases upwards for aprotic solvents, but that's only for halides, okay? That's only for halides. So even though if we went by this arrow, we would determine that oxygen must be the better nucleophile in an aprotic solvent, you would get that wrong, okay? You would get that wrong, so don't do that, unfortunately. So it's going to be S in this case. Anytime you're not talking about halides, when you're talking about this column, you're going to find out that sulfur is always going to be the better nucleophile than the oxygen. So now we're talking about the size and the polarizability, okay? So likewise, there's another textbook question who asks which one is a better nucleophile in an SN2 reaction. In an SN2 reaction, that's aprotic, and the answer is still S. Okay. Now, 64. Tert butylbromide reacts with ethanol. This is tertiary, so this must be an SN1 reaction. What is the fastest halide nucleophile? And this was a multiple choice. You had fluoride, iodide, bromide, but this is a trick question as well. There's also the option that all of these three will react at the same rate. And that's actually the right answer, okay? So because this is SN1, so all nucleophiles react at the same rate because the nucleophile is not in the rate reaction, is not in the rate expression. Okay, so we only get one of the reactants, we do not get the nucleophile in here. So the identity of a nucleophile does not matter in an SN1 reaction. So if you have the option, say all three of these will react at the relatively same rate. Unless one of these is in greater concentration, then that will be the most effective nucleophile. 1 bromopropane plus ethanol. This is primary, so this must be an SN2 reaction in an aprotic solvent. What is the fastest nucleophile of the following? So if this were a question asking about halides, you would think about the fastest nucleophile. The best one is going to be at the top for an SN2. But because you got your options between O and SH, the answer is once again going to be SH, because this arrow direction for nucleophilic strength and aprotic only applies to the halides, okay? So the S, the sulfur, is going to be the stronger nucleophile than oxygen no matter what solvent it's in. Okay, and this would not, both of these would not react at the same rate, because in an SN2 reaction, identity of the nucleophile does matter. And I want to talk a bit about leaving groups because it's easy to get them confused, I guess. So best leaving group is something that is a stronger acid. The worst leaving group is something that is a strong base. And in this problem 72, which of the following is the poorest leaving group? We think about pKa's, one of those things you memorize, and I made another video on that. pKa of hydride, 35. pKa of alcohol and its conjugate, 16. This is a pKa of an amine, so it's 40. This is more basic, so this is a worst leaving group. Okay, but keep in mind that if this were something like a plus up here, it's actually going to be a pKa of 10, so that's acidic. That's going to be a really good leaving group. But be careful if it says negative or a positive on this amide, on this amine. Sorry, not amide, amine. For this next problem, this is a conjugate of our alcohol, pKa of 16. This is a conjugate of a really strong acid, so the pKa is going to be super small, in the negative something. So this is more basic. That will be your worst leaving group. And last thing is, if a question asks you to identify the leaving group in the following reaction, be sure you choose the thing that's on the product side. It's easy to look at the reactants and say, hey, I got a substrate and it looks like this is going to be my leaving group in the substrate, but not really, this because this is a substrate and the thing that actually leaves is going to be the leaving group. So this is actually the leaving group. It's not going to be this little bit, but it's going to be the thing on the product side.